Hello everyone, welcome back to my channel. Today we are diving into how to optimize your OpenAI Assistant by dynamically binding vector stores. If you've been struggling with attaching large number of files or facing performance issues with your assistant, this video is for you. Let's start by looking at the two standard methods of attaching vector stores to your OpenAI Assistant. First would be during your assistant creation. When you create an assistant, you can select tools like file search or code interpreter and provide your vector store IDs in the tool resource option. Second, we have by attaching to a thread. So alternatively, you can attach a vector store directly into a conversation thread by adding your vector store ID in the tool resource. That means you can only attach up to 2 vector store to your assistant. So what if you have hundreds of thousands of files? You need to cram them into 1 or 2 vector stores. As these vector stores grow, you might encounter increased latency. So by increased latency, I mean the larger the vector store means longer search and retrieval times because more data has to be processed. And the second one would be precision versus performance trade-off. You might have to choose between the accuracy of your results and speed of the retrieval. So these issues can significantly hamper your performance of your assistant. So to tackle these challenges, I've discovered a partial solution: dynamic vector store binding. This method allows you to dynamically assign a vector store to your assistant based on user's initial input. So this is how it works. So initial message. So the user first sends a message to the chat completion endpoint with function calling enabled. Now the function calling processes this message and decides to what topic should be assigned based on the predefined criteria. Based on the topic, select the vector store ID, and using this information, we will initiate a thread with the OpenAI Assistant dynamically by attaching the appropriate vector store that got selected. This approach allows the assistant to be more responsive and efficient by only loading the relevant data. Let's make this concept clear with an example. So suppose you have a vast collection of documents categorized into 3 topics, which could be maths, physics, and chemistry. So you create your 3 vector stores on each subject. So on the right side, you can see I've created 3 vector stores for each of the topics. Next, you'll set up a function, enum values, math, physics, and chemistry. So this is my function, and these are the 3 values that a function can select based on the first message that it got. Right. Now the function analyzes the user's initial query and selects the corresponding topics. Now, let's go it one by one. So the initial question asked by user is, what is linear equation? It goes to chat completion APIs with the function call enabled. So by the looks of it, what is linear equation? We can say that it's a part of math topic. So my function call will return me a math subject, and here you see it will select the math, and based on the mapping that you have saved, it will select math vector store ID, which will be vs_math. So we will take this ID and we will combine this with our initial message and send it to the thread creation. Now let's look into the function that we will be defining. If you can see, I created a function by the name of getSubject, and in the description of this function, I said determine subject based on the question. So whatever the question will be asked, it will determine the subject of that question. And for the parameters, we only need one parameter, which would be out of these 4, right? So I will explain why I put other option in here. So after that, in the required section, I mentioned that subject is required, and that's it. Now let's see this in action. So I've opened a Postman and I've added the chat completion endpoint in here. And in the headers, you'll see that I've added my API key and the content type. And in the body, you'll see that I have defined my function in here. So let me show you the whole body actually. So I'm using GPT-4 Omni, and the first thing I'm adding is the system context message. So what I'm telling my chat completion API is that do not answer anything from the outside. Only use function calling. If none of the subject is found, use other value. So this explains the fourth option that I defined in a function, right? And also, if you look closer, so this is my function, and the second thing I added was the user context message, which would be my question that I'm going to send to the chat completion. So once I done this, I make sure that every initial question or any initial message sent by user will be processed through a function calling by making the tool choice required in here. So that will make sure that any message that we send via this method will go through the function calling, right? So now that I have everything set up, I will click on send, and it will give me an output from the four selected enum values. So I do send, and it takes some time, and in the response, you'll see that for my question, what is thermodynamics, it selected the physics option from here. And these are the arguments that I will fetch in my code and map my vector store ID with respect to it. So now imagine that I have selected the vector store ID that I got. So let's imagine I've mapped the vector store ID for the option that we received from the chat completion API. So let's say I've added this in here, and what I'll do is I'll create a thread and directly run it with the assistant. So I've added my assistant ID here. So this is my endpoint for directly creating thread, adding message to it, and adding assistant to it. So it will directly run with one single API hit. So added my vector store ID here, and I'm adding what is linear equation, okay, so it would be what is thermodynamics here. Thermodynamics. So this is the original question that we used in our chat completion, and we are using all this information. And in the body, in the header, it will be the same. It will be my API key. The OpenAI beta is the additional header that we have to pass. And now when I press enter, it will create me. So this is the thread that got created. So what I'll do is I'll fetch all these messages from this thread. So I'll copy and I go to the next tab. So this is the API for fetching, listing all the messages from a specific thread. So I pass the thread ID here. So now when I enter, it will give me the response. So this is the response that it fetched from the files. So if you can see that these are the annotations, that means this response came from the file. If you go down below, you'll see in the annotation, it will show that it's referencing these files. So now we've seen how this works in Postman. Let me show you how this works in actual code. So this is Apex programming language. So if you're not familiar with it, it's not that tough. So it's similar to Java. So let's start with this method that I created. So this method accepts the user message, the initial user message. So once it receives the user message, it sends this message to the OpenAI chat completion API. And these are all the parameters that we need to set. So this is my request body. So in request body, you'll see that in user context, I'm adding the escape message, which would be our user message. And I'm also defining the function here like we did. And so once we hit the API, we'll get the response. Now, we get the parameters from the response. So this code is all about getting parameters from the tool calls. And you can see that I'm fetching the function name and function arguments here. That means in the function name, I'll get the function that is called, and in the arguments, I'll get all the arguments from the JSON that got created or generated by the function calling. And from this argument JSON, I'm also fetching the list or the subject. Not the list, but just the subject I'm fetching from it. Now, I've also told you that you have to maintain a mapping in your code. So this is my mapping. So if the subject is math, I'm storing this vector store. Else, if it's physics, I'm selecting this. So you can do this kind of thing for other options as well. Now, once I have the vector store ID, I'll call this method, which will be an assistant. So I'm calling an assistant, and let me show you. So these are the same things. I'm attaching the request body, and the request body, I'll have the query, which would be the original message that we have, and the vector store ID. So I'm passing the vector store ID like this. Once you do it and you run this code, it will give you the response similar to what we got in our Postman. So by adopting this dynamic vector store binding, you overcome the 2 vector store limitation. So you no longer are restricted to just 2 vector stores. It can enhance your performance, like smaller topic specific vector store to improve your search speed and accuracy. You can easily manage a large data set by categorizing them into multiple vector stores. So there you have it, a dynamic approach to optimizing your OpenAI Assistant using vector stores. This method not only enhances the performance, but also provide a more tailored experience for the users. So the only issue I see with this approach would be, for example, I started this conversation by asking a question related to physics. So my initial message will be, what is thermodynamics? So it will attach the physics vector store, and it will start the thread based on that based on that subject. But in the same conversation, if I ask something related to mathematics, and I want that to fetch the mathematics vector store as well, this is not quite possible with this logic. But I'm sure that there could be a way of implementing more complex or more detailed function calling to overcome this issue. So if I see any solution to this issue, I'll create a video and keep you updated on this one. So yeah, if you find this video helpful, please give it a thumbs up and subscribe to more OpenAI Tech Insights. If you have any questions or need further clarification, just drop a comment below. Thanks for watching, and I'll see you in the next video.